Now, see here the ferromagnetic substances. In ferromagnetic substances, each atom of this substance is tiny magnetic dipole having permanent magnetic dipole moment. It means in the ferromagnetic substances also every atom behaves as a magnetic dipole and they have got their permanent magnetic dipole moment. But here in the ferromagnetic substances, atoms form very large number of small effective regions called domains. So, here in the paramagnetic substances, these dipoles were randomly oriented, but here there are the group of the atoms which have the magnetic dipole moment in the same direction. So, these small groups are referred as the magnetic domains are simply called, they are called domains. So, this is the one domain over here and this is the another one, this is the group of the atoms which have got the magnetic dipole moment in one direction. Similarly, this domain, it has got the magnetic dipole moment in one direction, similarly this and similarly this. But net magnetic dipole moment of this substance is 0 if external magnetic field is 0. As you apply external magnetic field, all these domains start aligning in the direction of the magnetic field and they ultimately align in this one. So, in this case I is much more greater than H. It means magnetization is much higher than the H and I does not vary linearly actually. So, the graph between I and H is shown here and after some time it achieves here the saturation. Now, if the I is much more greater than H, then chi m is also much more greater than 1 and mu r is much more greater than 1 and mu is also much more greater than mu naught. So, these are the properties of the ferromagnetic materials. So, now see here ferromagnetic substances when they are placed in external magnetic field, they magnetize in the direction of the applied magnetic field and most of the magnetic field lines are passing through the ferromagnetic substances and these type of the substances are strongly attracted by the magnetic field and they actually if they are placed in the non-uniform magnetic field, they move from weaker part of the magnetic field to the stronger part of the magnetic field. And here the behavior of the ferromagnetic substance in a magnetic field, external magnetic field is like this. It means the most of the magnetic field lines are passing through the ferromagnetic substances. And also if you increase the temperature of the ferromagnetic materials, their magnetization decreases with the time. With the temperature, as the magnetization decreases and keeps on decreasing, a time comes when the ferromagnetic materials starts behaving as a paramagnetic material. And after that this one we can write here chi m is equal to C upon T minus Tc here. Tc is called here the actually Curie temperature at which the ferromagnetic material changes into the paramagnetic substances. If the ferromagnetic material has been heated, beyond Curie temperature or beyond Tc and after that even if you cool down or decrease the temperature, the ferromagnetic material will not retain its original property. So, because it gets converted into paramagnetic, so now it will behave as a paramagnetic. So, these are the properties of the ferromagnetic substances.